classroom, looking at the first assignment in the stream, section 10.6, probability practice worksheet. See if you can pull that worksheet up. We're going to work through some problems, as I said, together. This is the homework. So just a practice worksheet to practice probability, getting more comfortable with probability and working through some extra examples. So once you have this pulled up, before we start answering question 1, which you can see we're going to use some dice to answer question 1, I want us to just kind of write the definition of probability, or how to find probability. Versus how to find odds. The odds is going to be the new part for today. So yesterday we did an experiment in class where we rolled dice a bunch of times. Some of you rolled it more than others, which is fine. But we were finding experimental probability because we were using the data that you gathered from rolling the dice. Probability is always out of the total. So on the bottom here, we would have total. So if you rolled the dice 75 times, that number should have been on the bottom every time you calculated the probability. On the top is what we call the number of outcomes. In our event, whatever event we happen to be saying, I'm just going to say in A. So A represents whatever we're finding. So the number of outcomes in A versus the total. So the bottom is always the total. Odds compares what you're asking or what you're looking for versus what's left over. So odds also is written as a colon expression instead of a fractional expression. So odds would be the number in event A, and you're comparing that to the number not in the event. So odds are comparing what you're looking for versus what's left over or what you're not looking for. Sometimes we say odds are for and against. So the odds of the Penguins winning the Stanley Cup, maybe those odds are like 16-2. 16 chances they will win versus the 2 that they will not, whatever it happens to be. But odds are for versus against, kind of comparing those two. So the first question that we're going to go through deals with the dice. And in this diagram, this is what can happen when you roll a pair of dice and the combinations that you could see. So think about the experiment yesterday. When we rolled the dice, there was always a number on the left and a number on the right. And that's what this diagram represents, all of the different ways that I could pull those two combinations of dice together. So Lizeth, if you look at all these combinations, how many total pairs of dice do you see in this diagram? So Lizeth, how many pairs of dice are in the diagram?
I'm trying to count them all.
Oh, okay. Well, how many rows are there? Let's make it a multiplication problem.
There's 6.
6 rows, and how many dice are in each row?
2.
But how many total pairs?
Oh.
I know it's kind
12.
of hard. So we have 1, 2, 3, 4, 5, 6. And then here's
Mhm.
1, 2, 3, 4, 5, 6. So we have 6 rows with 6 pairs of dice in each row. So how many would that be?
36.
Yeah, 36. There we go. It's a little harder with us being at home visually, kind of seeing what we're looking for. So we have total 36 options. All right, so some of the hardest part about probability is understanding what the question is asking for. When we find probability, the total should be in the denominator. So the total is going to be out of 36 for the probability questions. Now we need to see what we're looking for. So the first one says the probability of rolling exactly 1 6. So we're rolling 2 of these dice together. We want one of the dice to have a 6 on it. So if you look at the diagram, and I'd suggest just highlighting this and then erasing your highlights, we want to go through the dice and see which pairs have exactly 1 6. And I'm going to just start with this first column. And if I look down this first column, the last one, the last pair has a 1 and then a 6. So there's exactly 1 6 in that pair. If you look down the next column, so we're now in the second column. Going down that pair, there's a 2 paired with a 6. So that pair has exactly 1 6 in the pair. If I keep looking at that same column, I see a 3 and a 6, a 4 and a 6, a 5 and a 6. But then the last one is a 6 and a 6. And those are 2 6s. So that one doesn't count because there are 2 of them paired together. If you continue now moving up that column, there's a 6 and a 5, a 6 a 4, a 6 a 3, a 6 a 2, and a 6 and a 1. So all of those pairs contain exactly 1 6. So Lizette, how many pairs are highlighted?
$22.
So how many pairs did we highlight here?
I'm counting by twos.
Yeah, so they just count as a pair. So together, it's 1 pair together.
10.
There we go. Perfect. There are 10 of them. So that, yeah, and you were counting the individual dice. So we have to keep them as a pair together. And then we're going to reduce this. And remember, in your calculator, the calculator reduces fractions. 10 over 36, hit enter, and we get 5/18. So that reduces to 5/18. So that's our probability. The probability of rolling exactly 1 6 is 5/18. All right, now we're going to talk about odds. So odds is for versus against, or the number in A versus the number not in A. So 10 of the pairs had exactly 1 6. All of the rest did not. So Morgan, if 10 of the pairs contained 1 6, how many pairs didn't have a 6 in them?
26.
Yeah, 26, because that's the number left over. Morgan, what do you notice about 10 and 26? What do they total?
Wait, like 36?
Yeah, they make the total 36. So that's how odds work. So odds will always equal the total number. So the number that are for versus the number that are against. Morgan, one more question for you. Do you think you can reduce 10 26? Reduce it the same way you would reduce the fraction. So what could I divide into both of them?
Divide it by 2.
Yeah, divide it by 2. What do you get when you divide it by 2?
5 to 13.
Excellent. And that would be our odds. Questions with that first one? We're going to go through a whole bunch. So you can see the odds versus the probability. All right, let's try the second one. I'm going to erase my highlights. So if you wrote on yours, erase your board. And let's look at number 2, or letter B, I guess. Letter B says exactly one even number. So that means when you look at your pairs, remember you're looking at them as like a group together. One of the die should have an even number on it. Only one of them though. So if I look in this first column, so here's my column going down. The first one is a 1 and a 1. Both of those are odd. But the second one is a 1 and a 2. One of them is odd, the other one is even. And that's what we're looking for. So we want one of them to be odd, the other one to be even. So if I go down that column, there's a 1 with a 4 and a 1 with a 6. Riley, how about looking at the second column? Are there any pairs there that have one even and one odd?
2, 1, 2, 3,
Good.
and 2, 5.
What do you notice about the first column compared to the second column, Riley?
It's opposite.
Yeah, so if we continue that pattern, kind of getting the opposite, we can highlight all of the ones that have one even number. And you can see it's opposite every single time. So in the first column, I had half of them highlighted. In the second column, I have half of them highlighted. Riley, what would the probability be of getting one even number?
18.
Yeah, and what does that reduce to?
1/2.
Perfect, Riley. And again, notice that there's half of them highlighted in every column. So that probability is 1/2. All right, Riley, one more question for you. When we do the odds, 18 of them had an even number. How many of them didn't have even numbers? How many is left
18.
over? Yeah, what do you think 18 over 18 reduces to? What's 18 divided by 18?
1.
1, yeah. So as an odds, we say that reduces to from 1 to 1. So that means I have the same chance of getting a pair with an even number and a pair without an even number on them. So those odds are 1 to 1. Questions? I'm going to erase my highlights. I'm going to start over again. All right, the next one says, we want to find the probability of the dice having 2 odd numbers on them. So Maya, if you look at the dice, I'll start you off with the first one. We're looking at the first row. 2 odd numbers. So 1 and 1 are both odd. Do you see any other ones in that or pair in that row, Maya, that would have 2 odd numbers in the pair? Gianna, how about you look at that first row? What other pairs would have 2 odd numbers in the pair, Gianna? So we have a 1 and a 1. Are there any other pairs that have both odd numbers on the dice?
No.
So if you look down, so we have 1 and 2, and then keep going down the column. So 1 and 3, are both of those odd numbers? Is 1 odd and 3 odd?
Oh yeah, 1 and 3 and then 1 and 5.
Yeah, there we go. Okay, let's look at the second column. We want both of them to be odd. Does that happen at all in the second column?
No.
How about the third column?
3 and 1, 3 and 3, and 3 and 5.
Good, keep going, you're doing good.
Fourth column, no. And then the fifth column, 5 and 1, 5 and 3, and 5 and 5.
Nice.
And then the last column, no.
Awesome. Nice job, Gianna. So how many pairs do you count?
Nine over 36.
Perfect. Nice job. And then when we reduce 9 over 36, that reduces to 1 out of 4. Remember, if you're not sure how they reduce, just pop them in your calculator. 9 divided by 36 is 1/4. So 9/36 is 1/4. Now, when you go to do the odds, 9 of the pairs have 2 odd numbers. If I take away those 9, the dice that are remaining, there are 27 remaining or 27 left. So I write that as 9 to 27. So pretty much all the ones that aren't highlighted are the ones that are left. And those odds reduce to 1, 2, 3. All right, I'm going to erase, start over again. So the next one says the probability of rolling a sum of 13. Sum means they have to add to 13. So Logan, in this chart, where's the largest pair of dice? What could be the biggest option of the sum that we would have if we would add these together?
6, 6,
Yeah, what does 6 and 6 make?
12.
12. Is there ever a sum that's going to be bigger than that?
Nah.
No. So what's the probability of getting the sum of 13?
0.
Yeah, 0 out of 36, which is just 0. That can't happen. We can't have a sum of 13. So that's 0. Those odds would be 0 to 36. My odds, not looking good because it can never happen. Next one, the sum of 7. That means they have to add to be 7. So let's go back, look up here. We're looking for pairs of dice that add to be 7. Liam, do you see any pairs of dice that add to be 7?
I'm trying to look. Hold on.
That's fine. So kind of look at that. Just start with the first column. Start there. Do any of them add to be 7?
Yes.
Which one?
The bottom one.
Yeah, the bottom one. And then Liam, if you go diagonally upward, what do you notice about the next pair?
It adds to 7.
And then next pair that adds to 7 would be?
Diagonal.
Yep. And keep going diagonal. How many pairs add to be 7, Liam?
6.
6. Yeah. So notice that there's a pattern there. They're all on the diagonal, and that's going to happen with every single sum. The sum will always be on the diagonal of this diagram. So 6 out of 36 is 1 out of 6. That reduces to 1/6. The odds would be 6. And then the leftover is 30. Remember, that number should equal 36 when you're done. So 6 add to be 7, the rest do not. And that's 1, 2, 5. All right, last question on these dice, and then we're going to turn it over to Mr. King. The last one says, we want both numbers to be the same. So I want to roll the dice and end up having the same number on both of them. Caleb, can you look at a pair of dice here and tell me which pair have the same number on both of them? Morgan, do you see any pairs of dice that have the same number on both dice?
1 and 1,
Okay, keep going. Any others?
2 and 2,
Yep,
3 and 3,
good.
4 and 4,
Mm-hmm.
5 and 5,
And finally,
and 6 and 6.
how many of those options are there?
6.
Yeah. Which we said was 1/6. And the odds would be 6 to 30, or that's 1 out of 5. All right, so you'll see different questions with dice. And these are really pertaining to the questions we looked at yesterday. We're going to skip 2, 3, and 4. You're going to be able to figure out those probabilities there. Mr. King is going to go over some problems in 5 and 7 with you. So I'm going to flip the screen over to him.
So if we go down to 5, it's just one of those jar problems. We looked at one of these before. And jar problems with marbles, if you're pulling out anything like that, just it's a little bit more basic, but we're going to use odds for this. So the first thing we're going to do is read it and then determine what's the total number. A jar contains 3 red marbles, 4 blue marbles. One of the marbles is drawn at random. Okay, Liam, what's the total number of marbles? There's 3 red and 4 blue.
7.
Yeah. And then when you put the first question is very, very basic. When you grab one marble out, what are the outcomes that are possible? Liam? So what colors could they be when you pull them out?
Red or blue.
That's it. So possible outcomes are red or blue. And then Liam, I'm gonna keep you there. What's the probability of a blue marble?
It'd be 4 to 7.
Good. Now here's a little tricky one. What's the probability of a green marble?
0 to 7.
Awesome. And then last one, what's the probability of a red or blue marble?
7 out of 7.
Awesome job. And I'm going to keep you right there. Let's go back to part B. We know that the probability is 4 out of 7 for pulling a blue. What are the odds then? Remember, it's number of successes versus the number of failures.
Would be 4 out of 3.
Got it. How about for the green?
Would just be 0 to 0.
It would be 0. And then how many fail?
7.
7. Perfect. And then the last one, what do you think here?
Oh, it would be 7 out of 0.
Yep, you got it. A really good job. Does anybody have any questions about how we got any of those? Really good job, Liam. So we're going to skip down to number 7. It says use the sample space 1, 2, 3 all the way to 20. If one number is chosen at random, find. So we did one of these before where we went to 25. This one goes to 20. So first thing I'm going to want everybody to do is write out the numbers 1 through 20 right above. So we'll write out our sample space. 1, 2, 3. Just take a minute to do that. Okay, so I'll give you a second to do that. Okay, the first one says an even number. So one way you could do is you could go in and you could start highlighting all the even numbers, 2, 4, 6, 8, 10. The other one you could just think is how many even numbers? Riley, what percentage of numbers are going to be even through 1 through 20?
A half.
Half. Yeah. So you just think of it that way, that the probability of being even is 1/2. If you wanted to go and count them all, you'd get 10 out of 20. But if you just think about it, it's going to be 1/2. And we're going to look at examples like this when we get into the cards. Riley, what are the odds going to be if the event is 1/2 probability?
10, 10.
10 to 10, good. Or remember, because it reduces as well,
1, 1.
1 to 1, good. Yeah, so if you had that final answer of 1/2, there'd be 1 success to 1 failure to make up the total of 2. Now we're going to look at perfect squares. So perfect squares, 1 squared gives you 1. We did these before. 4 is 2 squared, 3 squared is 9, 4 squared, 16. So, Gianna, how many perfect squares are there?
Four.
Yeah, 4 out of
20.
good. What does that reduce to?
One fourth.
Not 1/4, 1.
1/5.
Good. What are the odds going to be? If your probability is 1/5, what would your odds be for 1/5?
20. But
Well, just think about 1/5. If there's 1 success out of 5, right? So it would be 1 success. Then how many failures would there be if it has to add to 5?
5.
Not 5,
4.
4. Good. So it'd be 1 to 4. If you kept them up there, another way you could do this is you count up all the ones I highlighted, which is 4 of them. And then after I counted up those 4 of them, you can count up all the ones that are not highlighted. And that's 16 of them. And then 4 and 16 reduces to 1/4. Okay, next. We're going to look for a prime number. So let me write these back in there. Can anybody tell me what a prime number is? Anybody? Caleb, Cameron, you know what a prime number is? Okay, a prime number is any number that can only be divided by itself and 1. So they want to find a number of primes, including 1. So I'll do the first couple. 1 can only be divided by 1. 2 can only be divided by 2 and 1. 3 can only be divided by 3 and 1. 4 can be divided by 2, so therefore it's not prime. 5 can only be divided by 5, which is itself and 1. But 6 can be divided by 2 and 3, so that one's not prime. 7 can only be divided by itself and 1, so it's prime. Who could finish the list for me? Maya, you think you can finish the prime number list? So we have 1, 2, 3, 5, 7. What's our next prime number? Morgan, can you tell us what the next prime number would be?
9,
Yeah, after that,
11,
after that.
Hold on,
13.
9 isn't prime. We can
Oh yeah,
divide.
9's
by
not
3.
prime. Yeah, nine can be divided by 3,
That
but
one's a
11
tricky
is.
one because you think it's odd. It should be divisible.
Yeah,
Oh, sorry.
That's all right, Morgan.
that's
No
my
problem.
fault. Yeah, I just started blobbing away over here. So 11, after 11 is
13,
good. Our next one,
17,
good. And last one,
19.
perfect. How many total is that?
9,
Yeah, that's where that 9 came in. 9 out of 20. Can that be reduced at all? No. So Morgan, what's going to be our odds if our probability is 9 out of 20?
I'm sorry, this part confuses me.
Okay. So if you our odds is going to be the number of successes, and then you put colons, and on the other side you have the number of failures. So if we look at a prime number, it's successful if it's a prime number. How many prime numbers were there?
9,
9. Good. If there's 9 numbers out of the 20 that are successes, how many are failures or non-prime numbers?
11,
Perfect. And that's it. Yeah, that's all you have to do for the odds. So those two numbers would be your total, reduced total.
I have a question.
Yeah.
Where did you get the 1 and 4?
On the one above it.
Yeah, like the 1 and 1.
So see, we'll start on the left-hand side here, okay? So if you look at the first fraction, 4 out of 20. If you're going to put that into odds, there's 4 successes and then 16 of those left over for failures. Does that make sense?
Yeah.
Now, when we reduce our fraction, you get 1/5. So that means for every 1 success, which means it's a perfect square, there are 4 non-perfect squares. And that's how you get your total of 5. So that's how we come over and we get our 1 to 4. If you put 416 in the calculator, 4 divided by 16, that reduces to 1/4. So odds work just like fractions do, where you can reduce them. We always want to have a reduced total. So you can do this when you're doing this problem like this. Once you get the 1/5, you don't need to do this part and reduce it twice. You can use the already reduced total, which is 1/5, and then bring that straight to your reduced odds. So if there's 1 success, that means there's 4 failures. Does that help?
Yeah.
Again, we'll do more of these tomorrow. But the rest of the time is yours. You have a couple more problems left, and we'll certainly go over them tomorrow. And we're just doing another review for your test on Friday.
Yeah, so the remainder of the worksheet that we did not go over is homework, and there's a few problems left. And then tomorrow, we will just work on another practice worksheet, review worksheet, and we'll work on it together in class, going through some more problems with probability and odds. Everyone have a great